Okay, in this video, we're going to be taking a look at how we can divide a vector into two components. What I have here is vector v, shown there in orange, and it forms an angle theta with the x-axis. So essentially, when a vector is like that, you will have two components, vy and vx. Vy being your vertical component and Vx being your horizontal component. So we're going to need to be able to calculate exactly what Vx is and what Vy is. And to do that, we just simply use trigonometry. So going back to your trigonometry, and what I have here is a right angle triangle and angle theta. And I know that my longer side is going to be my hypotenuse, my opposite side to angle theta is going to be my opposite side, and my adjacent side. And you probably remember your trig ratios. I'll just remind you here, just write it all down. Your sine theta is going to be opposite over hypotenuse, and your cos theta will be adjacent side over the hypotenuse side. Alright, so coming back to this diagram over here where we have a vector and we're trying to divide it into two components, what we can then do is use our trig ratios to find both components. So I'll start with Vy. Essentially, Vy is the opposite side of the angle theta here. So what I'm going to do is use the sine theta equals to opposite over hypotenuse. So then I end up with Vy being equal to V sine theta. Okay, so V essentially is my resultant velocity, which is my hypotenuse. All I did is used this ratio and made Vy the subject of the formula. For Vx, similarly, you're gonna get Vx being equal to V cosine theta, and I'm using the last ratio here to get that. So that's as simple as it gets, but we can look at an example. Let's say I have an object that is projected upwards at a velocity of, let's say, 25 meters per second. All right, it's a projectile motion. And then what we essentially get there is you have your resultant velocity, which is the 25 meters per second, but then it will have two components. I'll call it uy and ux. That's a right angle triangle. So in finding the components of this vector, simply what we then do is again use trigonometry. So uy will be equal to 25 sine 20 degrees, which gives you 8,551 meters per second. So that is the vertical component. Now for the horizontal component, we will have 25 cos 20 degrees, which gives us 23,492 meters per second. All right, that's as easy as it gets. If you have any questions, please just drop a comment in this video below.